Hello everyone, in this video I'll tell you how to use my water surface simulation tool. Firstly, you need to import it into the project, then go to Edit, Project Settings, and create new trace channel. Select Overlap in default response. After that, go to Water Surface Simulation, Blueprint, and drop this blueprint. Then, in the Line Trace channel, select Newly Created Channel. Now I'll show you how to make any actor work like water surface. To do this, you need to add an actor tag, water surface. You can write it directly or click right mouse button, then in scripted actions select add water surface tag. Also, instead of writing tag, you can inside tool click plus in water surface list and select actor. When in the actor, you need to enable generate overlap events and ensure that in collision presets newly created channel is set to overlap. After that, you need to go into the actor's materials, add a function, import dynamics, and all the parameters above this blank spacer, click right mouse button and promote to parameter. These parameters are needed for blueprint, so you don't need to touch them. Then, from materials attribute, you need to pull pin from normal to functions normal. Same with displacement. And connect functions pins with material attributes pins. Normal intensity and height intensity parameters changes simulation intensity specifically in this material. So you will configure these parameters for yourself. And you need to enable allow custom depth rates. That's all, but I want to add on my own that it's very convenient to adjust the intensity of simulation inside the game. For this you need to start the game, press Z on keyboard, enable afterwalk and slow-mo. Then just open actor's material instance and adjust normal intensity and high intensity parameters inside. Now I'll show you how to make any actor do impact. You need to add actor's tag dynamic object, and you know where is the same thing as with water surface. Then enable generate overlap events, and it's also desirable to enable two-sided in actor's material. That's all. Now I'll speak specifically about tool. Where is an interface in the tool, you can enable it by enabling Enable Widget. In game it enables by pressing Z on keyboard. Also, there is a save and load system. Here you need to write file name, this button writes all variables to file, and this reads. There are same things in the interface, so you can save all your changes after you set up the simulation and then load file to Blueprint. Save files are in the project folder, saved, save games. Also, there are some presets, you can see them names and purposes here. To load any preset, you need to write its number, not a full name, for example 1 or 2.2. Each preset has a different optimization for different cases. Preset number 1. Water surfaces are on same plane. That means that in the square around the player, all water surfaces should be on the same plane. I would like to clarify what it means. Let's take for example these two planes. If it's possible to take such a third plane so that it touches each vertex of the previous two planes, then this means that water surfaces are on the same plane. But if you shift one of the planes, then you will not be able to set the third plane. The same thing if you take for example a semisphere. It's no longer possible to set the plane in the right way. There are always vertices that don't lie on the plane. And this means that water surfaces doesn't lie on the same plane. Many actors. This means that it doesn't matter how many actors are simulated. Actor's impact doesn't scale by actor speed. This means that impact's force is always equals to a constant and doesn't depend on the actor speed. Preset number 1.1. Water surfaces are on same plane. I've already told it. Few actors means that the performance of the simulation depends on the number of actors. So the more actors, the more expensive simulation. Actor's impact scales by actor speed. This means that impact's force is depends on speed. So if the actor moves slowly, then it will impact weakly, and vice versa. Preset number 2. Water surfaces can be in any plane. This means that water surfaces in the character's square can has any shapes. You can even use some sphere and it will work fine. Many actors, I've already told it. Actor's impact doesn't scales by actor speed. I've already told that too. Preset number 2.1 and 2.2. In fact, if you take a closer look, you'll notice that they are almost same. Difference is only in simple group and complex group. In fact, they do the same things, but they have a different algorithm. So if you need any of these parameters, then look which one has better performance. The simulation. Simulation size is defined the size of the simulation in centimeters. Debug simulation size allows you to literally visualize simulation size parameter. Simulation resolution defines the resolution of the simulation in pixels. Fall of time is a time that simulation will wait after it realizes that it can be disabled. You can see status in the interface by the circle near the status title. Max angle defines the maximum angle relative to the XY plane under which the actor can impact. It is preferably to set it below 80 degrees. Flow multi allows you to simulate water flow if it's under the angle. You can enable it if you enable render custom depth pass in the water surface actor and enable allow custom depth writes in wear materials. And you also need to set flow multi greater than 0. The larger it is, the stronger the effect. However, it's a bit expensive because it adds a new scene capture that captures scene every tick. So if there is no need for this, then it's preferably to disable this parameter. For this you need to set flow multi to 0. Flow resolution defines height map resolution. I'll also note that this is still an experimental function, and if player moves quickly, simulation may break. As I said, you can disable it by setting flow multi to 0. Logic rate per second is FPS for all simulation logic. It's better to keep it low, around 7. Simulation FPS defines FPS for simulation, but it also changes simulation speed, so it's better to set it at 60. Extension speed defines how fast simulation becomes wider each time it's rendered. Damping is a decay rate of simulation. Normal softness is a shift in the derivative for generating normal maps. In other words, it's a free blur for a normal map. It's better to keep it somewhere for 10 or 15. Blur strength, blur steps. It's a post-process blur, so it doesn't affect simulation in any way, but simply blurs the final image. Before I go to the actor's impact tab, I'll first tell you how actors do impact. Scene capture takes a pic of actor's cut to texture. Then this cut drafts to simulation. Scene capture mods defines algorithms for this process. You can see where scene capture taking pics by enabling debug scene capture. In general, algorithms differ only how scene capture takes a pic of actor's cut and how this cut texture drafts to simulation. Scene capture can take a pic by actors no groups, actors simple groups, and actor MultiGroups. Actor's cut texture can be written to simulation by simulating together and simulating solo. And on the basis of these modes, 5 of these modes are being built. Firstly, I'll tell you about actors no groups. In this mode, scene capture takes a pic of all actors at the same time. Plane for scene capture takes from player or from any other actor. So it's better that all the water surfaces in the player's square lie on the same plane. Scene capture rate per second defines how many times scene capture takes a pic per second. Simulating together means that actor's cut will draft directly to simulation only once after scene capture take a pic. Actor's impact will be a constant and simulation performance doesn't depend on actor's count. And in this mode you need to set scene capture rate per second to 120. So now let's look at the first scene capture mode. Actors no groups, simulating together. Just what I was talking about. Okay, I am starting the game. This scene is under the angle, but at the same time on the same plane, where are also a lot of actors and everything works fine. Next one, simulating solo. This means that cut's texture will not be just a draft to simulation. Instead of this, it will, for each tick and each actor, do actor's mask, multiply by speed and move to actor's transform. This allows to use one cut texture for a few ticks, so we don't need to scene capture every tick, and so scene capture rate per second must be low, around 7. And also performance of the simulation depends on the number of factors. Now I'll show you everything I've told about. It looks nothing new, but when I push slightly ball, it started to do a bit impact. Okay, now about scene capture rate. If I set it to 1, cut's texture will be updated only 1 time per second, and it looks noticeable, but if I set it to 7, it looks well. I've ended up with the ways how actor's cut drafts to simulation. Now I'm only left about ways how scene capture takes a pics. Next one is actor's simple groups. It creates texture for each actor, and scene capture takes a pic of each actor individually to its individual texture. It's obviously expensive than previous mods, but this one allows water surfaces to be any shapes and in any planes. I start game and you can see that now scene capture takes a pics of each actor individually, but otherwise everything else works as in previous mods. Actors MultiGroups works same as previous mod, but now actors will make groups if it possible and render together. Groups inaccuracy defines how much different can planes be. Okay, now I'll show you how it works. You can see that on plane all actors captures together, and not on a plane you can see how actors trying to make groups. Difference between simulating together and simulating solo is same as I told before. Actually presets I told before differ only by scene capture mods, so you can navigate by it. Actor's cut resolution defines cut's texture resolution. This is a curve where time means cut's scale in centimeters and value means cut's resolution in pixels. Also, you can debug cut resolution. It's better to set cut's resolution as small as possible, because noise appears when resolution is high. Usually 2 points enough, 1 point to 0 and another to simulation size, value is 10 times lower. Scene capture offset. These parameters additionally increases scene capture size in centimeters. Speed threshold is a speed below which actors will not be able to impact. Actor's strength defines actor's impact strength. Capture depth defines depth for scene capture in centimeters. You can see it by enabling debug scene capture. Size of these bounds shows capture depth. If you have any questions, you are welcome to comments. That's all, thank you for watching.